In this module, we discuss photoelectric effect in the form of MCQs. Question number 1. The work function for a metal surface is 4.14 electron volt. The threshold wavelength for this metal surface is option A 4125 Armstrong unit, option B 2062.5 Armstrong unit, option C 3000 Armstrong unit, option D 6000 Armstrong unit. Threshold wavelength is the maximum wavelength that the incident radiation must have so that the photoelectric effect takes place. The work function is the minimum amount of energy required to induce the photoemission of electrons from the metal surface. In the problem, work function is given. It is 4.14 electron volt. The joule is a unit of energy while the electron volt is a unit of momentum. Hence, the given value for work function must be converted into joules. Converting between these two units require knowing the conversion factor, which is 1 electron volt is equal to 1.6021 into 10 to the power minus 19 joules. To convert electron volt to joule, simply we have to multiply 4.14 with 1.6021 into 10 to the power minus 19 joules. When we substitute the value in the expression, threshold wavelength is equal to velocity of light upon wave function. We obtain 3000 Armstrong unit. Hence, the correct answer option C, 3000 Armstrong unit. Question number 2. A surface ejects electron when illuminated with green light, but electrons are not ejected with yellow light. The photoelectrons will also be ejected on illuminating the surface with option A infrared rays, option B ultraviolet rays, option C red light, option D orange light. We know that frequency and wavelength of electromagnetic waves are inversely related. When green light falls, the electrons emits, whereas when yellow light falls, the electrons are not emitted. So we can say that the electrons are not emitted with high wavelength. In vice versa, we can say that with a lower wavelength than green light, the electrons do get emitted. Therefore, only UV rays will emit electrons as all other options are of higher wavelength. Hence, the correct answer option B, ultraviolet rays. Question number 3. The stopping potential in the context of the photoelectric effect depends on the following property of incident electromagnetic radiation. Option A frequency, option B amplitude, option C intensity, option D phase. Stopping potential is the potential required to stop ejection of electrons from a metal surface when incident beam of energy greater than the work potential of metal directed on it. Stopping potential is equal to half into h mu minus W naught. Here, h is Planck's constant, mu frequency, W naught work function. When we look at the expression, in the right hand side, everything is constant for a particular material except the frequency mu. Hence, the correct answer option A, frequency. Number 4. The work function of potassium is 2.30 electron volt. UV light of wavelength 3000 Armstrong unit and intensity 2 watts per square meter is incident on the potassium surface. The maximum kinetic energy of the photoelectrons. Option A 1.84 electron volt. Option B 2.30 electron volt. Option C 1.30 electron volt. Option D 1.60 electron volt. The energy of the photon is E is equal to hc upon lambda. When we substitute the values, we obtain 4.14 electron volt. The maximum kinetic energy of the photoelectron is obtained by h mu minus work function. When we substitute the values in this expression, we get 1.84 electron volt. Hence, the correct answer, option A, the maximum kinetic energy is equal to 1.84 electron volt. Question number 5. The number of photoelectrons emitted for light of a frequency mu is proportional to option A, threshold frequency, option B, intensity of light, option C, frequency of light, option D, frequency of light minus threshold frequency. Electrons are ejected only when the light of frequency greater than the threshold frequency is incident on the metal surface. The intensity of light refers to the amount of photon energy per unit area. So, the greater the intensity of light, more will be the number of photons, and as a result, more will be the number of ejected electrons. Hence, the correct answer, option B, intensity of light. Question number 6. Choose the correct option among the following regarding work function of material in a photoelectric effect. Option A is different for different materials. Option B is same for all metals. Option C depends upon frequency of the incident light. Option D depends upon intensity of the incident light. In solid state physics, the work function is the minimum thermodynamic function needed to remove an electron from a solid to a point in the vacuum immediately outside the solid surface. The work function is not a characteristic of a bulk material, but rather a property of the surface at the material, and it varies for different metals. For aluminium, work function is 4.08, beryllium 5.0. For cadmium, work function 4.07, calcium 2.9. For carbon, work function 4.81. For nickel, 5.01. Potassium, it is 2.3. For sodium, work function 2.28. Hence, the correct answer option A, different for different material. Question number 7. The threshold wavelength for photoelectric effect of a metal is 6500 Armstrong unit. The work function of the metal is approximately option A 2 electron volt, option B 1 electron volt, option C 0.1 electron volt, option D 3 electron volt. We know that the minimum energy required to produce photoemission of electron is said to be work function. In the problem, threshold wavelength is given. It is 6500 Armstrong unit. It has to be written in meter scale. 6500 Armstrong unit is equal to 6500 into 10 to the power minus 10 meter. We know that work function is equal to hc upon lambda. That is, work function is equal to velocity of light upon threshold wavelength. When we substitute the values of Planck's constant, velocity of light and threshold wavelength in the expression, we obtain 2 electron volt. Hence, the correct answer option A, 2 electron volt. Question number 8. The work function of a metal surface is 6.2 electron volt. Find the threshold wavelength of the metal. In the problem, Hc value is given. It is 1240 electron volt nanometer. For this question, 4 options are given. Option A 400 nanometer, option B 360 nanometer, option C 200 nanometer, option D 100 nanometer. Hc value is given in the problem. It is 1240 electron volt nanometer. Work function is also given. It is 6.2 electron volt. Work function is equal to hc upon lambda naught. From this expression, we can write threshold wavelength lambda naught is equal to hc upon work function. When we substitute the values in this expression, we obtain 200 nanometer. Hence, the correct answer option C, 200 nanometer. Question number 9. The work function of a photometal is 6.626 electron volt. The threshold wavelength is option A, 3920 Armstrong unit, option B, 1875 Armstrong unit, option C, 186.6 Armstrong unit, and option D, 18,666 Armstrong unit. We know that the minimum energy of incident radiation which is required to eject the electrons from the metal surface, is defined as the work function of that surface. Threshold wavelength is equal to hc upon W naught. Here h is Planck's constant, c velocity of light, and W naught is work function. When we substitute the values in this expression, we obtain 1875 Armstrong unit. Hence, the correct answer option B, 1875 Armstrong unit. Question number 10. The work function of silver is 4.7 electron volt. A radiation of wavelength 300 nanometer is incident on a silver surface. Will photoelectrons be observed? Let us find the answer. Energy of the incident photon is E is equal to h mu. We know frequency and wavelength are inversely proportional to each other. Hence, E can be written as hc upon lambda. Substituting the values, we get energy of the incident photon is 4.14 electron volt. The work function of silver is given in problem is 4.7 electron volt. Since the energy of the incident photon is less than the work function of silver, photoelectrons are not observed in this case.